Alright, so you've probably been looking at this problem and it looks absolutely horrific, right? How in the world are you supposed to do this? Because I'm kind of implying that what you need to do is, like, do some weird complex manipulation of nodes. And sometimes you do. Sometimes you have to do weird manipulations of the next pointers and the like. But most of the time, it's trying to be straightforward. Reversing a linked list in place just by manipulating all the pointers and what the head and what the tail is, that's actually a pain in the butt. That's actually pretty tricky to do. It's actually, I feel like that's something you need to know the trick before you actually do it. And I'm not a fan of giving you stuff that has secret knowledge in order to do that. No. So whenever you see something that looks really difficult, see if there's an easier way we can do it. Right? How can I reverse a linked list? Right? I've got 1, 2, 3, 4, 5. I'd like to get 5, 4, 3, 2, 1. Well, what I could theoretically do is that I could just have this temporary. Let's see. What would be easy is that if I had a temporary empty list over here, and what I did is that I removed 1 from the list, right, and plopped it over here. Then I removed 2 from this list and plop it over here. Then I removed 3 from this list, plop it over there. Move 4 from this list and plop it over here, and remove 5 from this list. And then plop it over here. And then, if I can convince the object that this was the original list and not this, without it being any the wiser, then I'm in business. So we're going to focus on that. So first step is basically moving everything into a new list in reverse order. And then we are going to go ahead and try, and then the next step is convincing Java that this was the original list. So that's not too hard. So we're going to make a new temporary list, circular linked list. Oh, not circular, I'm in a doubly linked list. Doubly linked list, E is equal to a new, let's go with temp is equal to a new doubly linked list, right? Because we're going to be throwing away this linked list once we're done with it. Okay? So while this dot size not equal to 0, what shall we do? Well, we are going to remove the first item in the list. So this list, I'm going to use this explicitly here so I know which one I'm moving. This dot remove index 0. And I'll just go ahead and say e item is equal to this dot remove. And then let's see. This dot add, not this, temp dot add. Let's see, we want to add it to the head of the list. We're going to add the item there. Right, why do we do that order? Well, because we're removing the thing from the beginning and we're adding it to the beginning. Then we're removing the thing from the beginning, adding it to the beginning. Right? So in our example over here, right, remove the thing from the beginning, remove 1, add it to the index 0. Remove index 0 over here, add index 0 over here. Remove index 0 over here, add index 0 over here. And because we're dealing with a linked list, we really have no shifting to deal with in either of those cases. Okay, so now the original list is empty, it's size 0, and now we've got our temporary list. So how can we go about back doing this? Well, there's 2 ways to do this. We can now just add everything back into the original linked list, right? We could do this. We could like flip it around. While temp.size is not equal to 0, temp.remove index 0, and instead of adding it onto the index 0, we're just going to add it onto the end, right? So that would effectively do, right, 4, 5, right? We'd be starting from here. What we could do is we could do something like this, 5, right, remove the head, put it on the tail, remove the head, put it on the tail over here, and so on and so forth. That's what the code. Whoops, that's if I finished going through this, that's what the code I was doing would just do. So kind of using a new list as kind of a temporary buffer to flip everything around and then put everything back in order. Okay, and believe it or not, this takes O of n time. Okay, another way to do this is if we want to get clever, because we're in, now that I highly recommend kind of against doing this, it feels really icky to me, because we're inside of the doubly linked list class, we're allowed to do this. Or rather, we can do this. We can say this dot head is equal to temps dot head. And this dot tail is equal to temp dot tail. And then, of course, we just need to make sure the size matches. This dot size is equal to temp dot size. And we have access to those private variables because we're inside. And that feels really weird to do. I prefer the other way because it's just seems a bit more correct. But this is another perfectly acceptable way to do this. Alright. So that's what I got there. Alright, so next one. We'll do the triple cut next video.